Okay, guys. What did you get up to, guys? Okay, guys, can you please say it? Hey, how? Okay. So what did we get up to? We did concentration, right? And we saw how does concentration affect the equilibrium position, right? Now we're going to get to temperature, right? And we see how temperature affects the equilibrium position, right? Right? Yes. So this temperature thing, guys, it's a bit tricky, but not that much, right? I know that's a bit. Yeah. So let's get to temperature. So let's get to temperature, right? So temperature now depends on the nature of the what? Of the reaction, right? It depends on the nature of the reaction. Right? What's wrong? So what? Guys, it doesn't matter that
want to see. Yeah.
Okay. So talking about temperature, right? And I said temperature depends on the nature of the reaction, right? It depends on the nature of the reaction, right? So the reactions we have endothermic and exothermic. Do you still remember what is endothermic and exothermic?
Yes.
So if we are having a positive enthalpy change, what do you have?
Endothermic.
What is this?
Endothermic.
What is this?
Endothermic.
Is it endothermic? Are you sure?
Yes.
It is endothermic, right? It means that this, it is greater than 0, right? And if we are having something like this, what is this? Exothermic. So this is that our enthalpy change is what? Less than 0, right? So guys, I want us to briefly talk about this, right? And talk about what happens, yeah? So with the exothermic reaction, what happens? Yes.
Heat is lost.
Is heat lost?
Energy is lost.
Energy is lost how?
Yeah.
How?
Energy.
Okay. So this
It releases
it releases
heat.
It releases heat. Ne? So the exothermic release heat, right?
Yes.
So this reaction releases heat, right? What about this one? Absorbs heat. So once you understand what happens between endothermic and exothermic, you're halfway done with explaining what happens if we increase or decrease the temperature of a closed system, right? We are halfway done to solving what happens if we change this factor according to what? Kulichatalia, right?
Yes.
So we are agreeing that this is exothermic, it releases heat. This is endothermic and it absorbs heat, right?
Yes.
Right? So it means that if we are reacting the exothermic reaction, it means that at the end of the day or at the end of the reaction, the container that reaction is happening in, it will be what? Warm, right?
Yes.
Right? The container will be warm, meaning that it released energy, right? It released heat. Do you get my point? So I'm trying to say, if we're having a container here, a beaker, right, that is closed, and an exothermic reaction is happening inside here, right? Exothermic reaction is happening inside. So it means that after the reaction is happened, it means that the beaker will be warm or it will be hot. right? Do you get the point?
When what?
When an exothermic reaction is happening inside the beaker, after the reaction is complete, you feel that there's what?
Heat.
There's heat. Because this releases heat. Are we agreeing to that? Are we agreeing to that? And if an endothermic reaction is happening, you know that endothermic, the enthalpy is greater than 0. So if you are holding a beaker while the endothermic reaction is happening inside, how would you feel? Cold, right? Or cool, right? Because an endothermic reaction is happening and it does what? It absorbs
Heat.
right? So if you try to think in that way, that an exothermic releases heat and exothermic releases heat and endothermic absorbs heat, then we are halfway done, right? So in this case, when we are talking about this topic, we are talking about what? The forward reaction and the reverse reaction, right? Yes. So, is there anyone who can
Tissue.
Can I raise? Okay. So now what I want you to do, guys, is to listen to me very good. Eh? Very what? Careful. Eh? Because once you miss this, you miss the bus. Eh? And I don't want you to miss the bus. So stay with me, stay in this bus. Eh?
Yes.
So let's try to see this reaction. Eh? They told us that nitrogen reacting with and then this is as 2NH3 and then this is as 2NH3. Okay, so this they tell us that makes stop what you're doing. Stop what you're doing, Daniel. Stop what you're doing. Right? So, what does this mean? They give us something like this. Eh? So, if they give you something like this, what they're automatically telling you is this. What is this?
Exothermic.
I mean, what is this? So, what is this saying?
Exothermic reaction.
Yeah?
Exothermic reaction.
Is exothermic reaction, right? So, it means now the forward reaction is exothermic, right? But this thing is happening both ways, right? This is a reversible reaction. So it means that if your forward reaction is exothermic, it means that your reverse reaction is what? Endothermic. So it means that going back it is endothermic, right? So going backwards is endothermic, right? So I want to ask you a question, guys, right? Right? So, which reaction here will increase the heat in the beaker? Yes, the forward or the reverse?
Who is the heat?
Yes, which one will increase the energy?
Is the reverse.
Increase
Reverse.
the forward reaction because it is exothermic. We said exothermic releases heat. So it means that this forward reaction increases heat, right? What about the reverse reaction? It absorbs the heat. So it means that it decreases the heat, right? So once you understand this, you have to do that, right? Yes. Because this absorbs the heat. Endothermic absorbs the heat. We agreed on the previous page that if an endothermic reaction is happening, it absorbs energy, or it absorbs heat, right? Do you get what I'm trying to say? We said once you are holding the beaker where the endothermic reaction is happening, you feel coolness or you feel cold, right? So it means that it absorbs the energy, right? But once an exothermic reaction is happening, you feel the heat because it is releasing the what? The heat, right? So I'm saying now, if the forward direction is exothermic, it means that it does what? It increases energy in the what? In the system, right? Right?
Yeah.
And the reverse direction is endothermic. It means that it what? It decreases energy in the what? In the system, right? So now we are going to try to explain this concept in terms of Le Chatelier, right? So a question comes and says, explain what will happen if we increase the energy in the what? In the system, right? So first let's talk about what will happen if we do what? Increase the energy. What will happen if we increase the temperature? Right? So it means that you are placing a beaker there and you are starting to what? To increase the what? The temperature, right? So what will happen to this system? Okay. So it means that increasing the temperature will increase the heat in the system, right?
Yeah.
So let's start. Increasing the temperature increases the heat in the system, right? Here we are clear, right? We are still together, right?
Yeah.
Increasing the temperature increases the what? The heat in the what?
System.
In the system. But according to Le Chatelier, a change in any of the factors will cause the system to what? To change in such a way to what? To reduce the effect, right? So we are going to say, according to Le Chatelier, the system will change in such a way to decrease the what? The change, right? Or to eliminate the change, right? So according to Le Chatelier, the system will change in such a way to decrease the what? The effect. That was what? That was done to this system, right? So let's write that, right? Effect here. To decrease the effect. Again. So we have increased the temperature. So the system will try to do what? To decrease the temperature. Because we increase the what? The temperature, right? So the system will try to decrease the what? The temperature. Because we have to increase the temperature, so the system will try to do what? To decrease the temperature, right? And which of the reactions decreases the temperature? Endothermic. Endothermic reaction always decreases the what? The temperature, right? So we are going to write endothermic decreases the what? The temperature. So if the endothermic reduces the temperature, which one is the endothermic? Is it the forward or the reverse reaction? The reverse reaction. So it means that in this case, reverse reaction will be favored. Since it is endothermic. So if the reverse reaction is favored now, what is going to happen in the system? It means that we are going to create more what? Reactants than products, right? So we're going to create more reactants than products. So if we have created more reactants than products, where is our equilibrium going to shift? To the left. So it means that our equilibrium shift left. Did you see what happened? Did you see what happened? I'm going to repeat this again, right? I said what will happen if we increase the temperature, right? Increasing the temperature increases the heat in the system. We are still together so far, right? So if the heat is increased in the system, according to Le Chatelier, the system will change in such a way as to what? To reduce the what? The effect that was done, right? And so it means that the system will try to what? To decrease the what? The temperature, right?
Yeah.
And the endothermic is the reaction that what? Absorbs the heat. So it means that decreases the what? The temperature, right? So according to this case, the reverse reaction is the endothermic. So it means that the reverse reaction will be what? Favored in order to decrease the what? The temperature. So if the reverse reaction is favored, it means that we are creating more what? Reactants than products. It means that our equilibrium shifted to which direction? Left. Right? So the most important thing is to understand what does the endothermic reaction do? What does the exothermic reaction do? Right? And then from then, now you check your equation. Which one is the endothermic reaction and which one is the exothermic reaction? Then you're done. Right? So now let's try to see what will happen if we do what? If we decrease the what? The temperature instead of increasing now. Right? So here let's try to see what happens if we decrease the temperature. Are we together in tonight? Right?
A minute.
Yes.
Like one. Like numbers already. Like numbers of reactants, and that is nitrogen and hydrogen will be like numbers of fixed things like hydrogen. Can I because the reactants, reactants, like sodium, nitrogen and hydrogen.
But okay, I'm getting your point.
Yeah.
I'm getting your point. But is there a risk in writing the reactants will increase or decrease? Because already we know which ones are our reactants, right? And which ones are our products. So in this case, our reactants are this and this. And our product is that.
Okay.
Right? So there's no risk in writing the reactants for the product. Right? But if you want, you can also say, okay, nitrogen and hydrogen will not increase or decrease, however the situation is. Right? So now they said, what will happen if what? If we decrease the temperature, right? If we do what? If we decrease the temperature, right? What do we know? We know that decreasing temperature means we decrease the heat, right? Heat in the system, right? Decreasing the temperature means that you have decreased the what? The heat in the system. And according to Le Chatelier, the system will move in such a way as to what? To re-increase the heat, right? So, according to Le Chatelier, right? The system will move in such a way to reduce the effect. Right? So it means that in this case we have decreased the temperature. So it means that to reduce the effect is to what? To re-increase the what? The temperature, right? So we're talking about re-increasing the heat, right? So according to Le Chatelier, the system will move in such a way to reduce the effect. Right? So what will happen now if, according to Le Chatelier, we're trying to reduce the effect? Decreasing the temperature means we decrease the heat in the what? In the system. Right? So according to Le Chatelier, the system will move in such a way to reduce the what? the effect, right? So it means that the system will try to what? To increase the temperature, right? Right?
Yes.
So, increasing the temperature. No, sorry. So, actually now we're trying to increase the temperature, right? And exothermic reaction increases temperature in the system. We've agreed to each other that exothermic increases temperature, right?
Yes.
So it increases temperature, right? So what will happen now? What will happen now? So it means that exothermic reaction increases the temperature in the what? In the system, right? So it means that according to this, or in this case, the forward reaction is exothermic, right? So it means that the forward reaction will be favored, right? So if the forward reaction is favored, what is going to happen? We're going to create more products than reactants, right? So it means that we're going to create more products than reactants, right? So if we've created more products than reactants, what is going to happen? Equilibrium will shift to the right. So equilibrium shift right. Can you see that? So like I always say, guys, you want to get this on the first go, right? But the only medicine that you can use is to try to practice and practice until you are perfect, right? Yes. Than reactants. So we're going to create more products than reactants. So that means that our equilibrium will shift right. Is it making sense? Yes. Okay. So now we are going to have a different equation from this, and we are going to try to explain what will happen if we increase or decrease the temperature in the system, right? Okay.
Can you please, can I go 2 minutes? Can I finish to go 2 minutes?
It's such a way to reduce the effect. Increasing the effect.
What do I do? You have more.
So now we are going to have a different situation, right? We are going to have carbon dioxide, yes, being added, hydrogen, yes, giving us water, yes, plus CO, and the H is written. Okay, so what is the meaning of this? What is the direction, the forward direction there, according to what you wrote there? The forward direction is endothermic. So it is that going there it is endothermic, right? And going backwards is what? Exothermic, right? So now, I'll request any volunteer. Anyone wants to volunteer to come and explain to us? Anyone who wants to volunteer?
Huh?
Okay, you can come. You can come. So, what you're going to do now is that you're going to explain to us what happens if we decrease the temperature. what is happening if we decrease the temperature in the system, right? So we can explain. If we decrease the temperature,
If we decrease the temperature in the system, according to nature, we can just think the system so that decrease the temperature. That does not decrease the temperature anymore.
Decreasing it.
is decreasing heat.
So,
Yes. Yes.
So, endothermic reaction will be there. So the what reaction will be vapor.
Why? Because the exothermic reaction do what?
Yeah?
It releases energy, right?
This is energy.
Mm.
And we have more
Products.
products than the nature.
So equilibrium shift to side. Yes. Something like that, right? Did you understand that? So let's re-explain this. So we said what happens if we decrease the what? The temperature, right? What happens if we decrease the temperature, right? So decreasing the temperature. The temperature means you have what? You have decreased the heat of the system, right? So if you decrease the heat of the system will try to do what? To re-increase, right? So according to Le Chatelier, right? The system will try to re-increase the temperature, right? The system will try to re-increase the temperature, right? So, exothermic reaction increases the what? The temperature, right? So if the exothermic increases the temperature, right? It means that it should be what? It should be favored, right? So according to this, in this case, the reverse reaction is exothermic, right? And will be favored, right? So if the reverse reaction is favored, it means that more reactants are going to be formed than what? Than products, right? Yes. So it means that more reactants are to be formed than products, right? So it means that our equilibrium will shift to side.
To the right.
So
To the left.
equilibrium shift left. Just like that.
Yes, it is.
Just like that. Any complication? Yes.
According to Chagras-Lee, the system will try to, if I said the system will try to reduce the effect,
Yes.
is this correct?
Yes. So the effect that was done is decreasing the temperature. So reducing the effect is what? To increase the what? The temperature. And exothermic reaction is the one that what? That increases the temperature. So in this case, the reverse reaction is what? Is exothermic. So it will be what? To be favored. Right? So it means that more reactions are going to be formed than products. So our equilibrium shifts where?
Yeah.
Okay, we said when exothermic reaction is happening, what happens in the surrounding? If exothermic reaction is happening, what happens? Oh, have you seen you have watched the movie? Have you seen a bomb blasting? What happens there? That is an exothermic reaction.
Well,
It releases a lot of what? Energy, right? So it's more like when an exothermic reaction is happening. It releases energy, it releases heat, right? So when it releases heat, so it means that once that reaction is happening, energy is what? Is released. So it means that the surrounding becomes what? Hot. So it means that if it happens, the surrounding becomes what? Hot. So it means that in that case it is also increasing the what? The temperature of the system. If it happens.
What about condensation?
Condensation.
Yes.
What kind of reaction is condensation?
I'm not sure, but I think condensation
Is it endothermic?
I think so.
what is
I think
but maybe I think six of it they will be what is it? Condensation.
You can go and find out what is it. Is it endothermic or is it exothermic?
Condensation.
Condensation.
It's the end of the
Yeah, but maybe it is endothermic because there will be there will be friction of
So guys, this hey guys, Enda. So these are exothermic and endothermic only apply to when you are doing what? Temperature, right? When you are explaining the temperature, right? Is it clear? Yeah. And when you are explaining the concentration, we use the word that if this side the concentration is increased, so the system will try to decrease this side. So creating that side, right? If I mean on concentration, right? If we increase the concentration of this, the system will try to decrease this, right? Yeah. So it means that the forward direction will be favored, right? And then with pressure, we are going to see what happens with pressure more, right? But with temperature, did you understand what happened? Did you understand what happened?
Yes.
Did you understand what happened with temperature?
Wouldn't then see kayak endothermic as if it's and then temperature will decrease. And then when it decreases, it means that
Okay. Maybe let's do like this. Can you please try to explain what happens if we increase the temperature in this situation?
Okay.
If you, I mean, let her explain, and then she should correct her mistake.
if we increase the temperature.
Yes. If the temperature in this situation is increased, what happens?
Okay, kayak endothermic because
No, talk about it step by step. Like, talk about increasing the temperature. What happens if you increase the temperature?
okay, increasing the temperature increases the temperature of the system.
Yes.
And then according to interthermal temperature, the system will try to reduce the temperature, and then from there the endothermic reaction is decreased.
Why? Because endothermic do what?
It absorbs and then after that, this is what we are doing.
Okay. So you said endothermic would be favored, right? And now you check to your situation. Which one is endothermic reaction? Is it the forward or is it the reverse? So it means that the forward direction is favored. So once the forward direction is favored, it means that we are creating more products than reaction. So it means that the equilibrium is to what? Enthalpy change.
Let's go on.
Okay, enthalpy change. No, this one is positive. So this only explains the forward direction, right? So this explains the forward direction, right? So did you understand this?